Okay, let's start where we left off last time. Last time we talked about temporal inference, how to form two types of statements. The first one being of that form, and the second one, which we call sequences. Maybe so from event A and event B, we can derive both the implication that A implies B with induction as we had. This one intersection. We also saw how it happens. Namely, here we have NARS. And here there is some kind of what we call event back. And or events enter an event back, and event back creates sequences like A and B, B, and also creates implications, and the implications go into NARS like A plus B. So this is the basic structure, so our input events go through event back, interact with already existing events in event back, which are either atomic, like A and B, or compound events, sequences, and additionally, whenever such an interaction happens, there is also implication formed, a corresponding implication which enters NARS. So this is the overall design, except that in a large-scale system we will have different sensory channels, like one for vision, and one for sound, for instance, which all of them do modality-specific processing, and they feed some summary or summarized events into NARS, which is this block, basically. But all of those events at first enter the event back, and this is where different modalities are combined. Where, for instance,
excuse me. Now by NARS you mean the memory, right?
Oh, sorry. Exactly.
The main memory.
Exactly.
Okay.
This should be memory. And this entire block is NARS. No, it's correct. And usually the vision and sound channel, it depends if you want to see them as part of NARS or as some external plugin which attaches itself to NARS. But all of those channels will report events into NARS, and since they report input events to NARS, they will at first go to event back, and this is where the different modalities are then combined, and where relationships like A implies B or predicts B will be formed. So
again, sorry for interruption. We really need someone who is good at using graphics software to draw some standard kind of diagram for all of our documentation, like this kind of picture we are going to need it again and again. Or a picture for, say, a concept structure, or a bag internal structure, and so on. We really need, who is good at those software. We really need that kind of stuff.
Just draw. Well, I'm okay with graphic software.
Yeah, at least we can begin to put together a list of diagrams which is central to the teaching material like this one. We really need a very good one for this kind of thing. And also maybe a couple either drawing or we just take a screenshot for say conceptual network within the system. And that will help a lot, I guess, when you're doing tutorials.
That's
Okay,
true.
okay, I can continue.
And with this design, it's already possible to see certain how should I say, to do multi-step conditioning, like we had the sequence of letters last time where we had ABC, and then later only A, for instance, or only B, and no C happening. And so it's, with this mechanism it can already see patterns like that A and B together leads to C. And this is important. So far, this is only a passive system which predicts events based on the occurrence of other events. But it will become interesting if B itself is an operation event, something the system, an event the system can realize by itself. So when we have something like this, A, and some operation, and then this leads to C. This is a form of procedure knowledge, which is basically a special case of the case which we already handled this way, where just B is some kind of event which the system can invoke by itself. So we have operations. And those procedure knowledge like this is important for the system to realize gores. For instance, if it has the gore C and it observes A, the event A, this is just means event, or now is probably better. So this specifies the occurrence stem or the tense of the event, which means it's happening now. And if this is the case, if it observes a certain event and it has a certain gore, for instance, it wants to realize C, and it observes A, then it knows it needs to invoke this operation to realize C. And exactly. So and this procedure knowledge is basically everything the system needs to build to be able to play things like a Pong or a microbot. The examples we have, they are all based on learning such statements. And of course there can be multiple events in the context under which operation leads to a certain consequence. There's one issue now. If operations are just handled like usual events, so for instance we can have something like up. If it goes through this mechanism, then we will derive statements like op A, op 2, for instance. And what we tried is to make sure that the system only only derives or has a strong bias in deriving statements of that form, because in our experiments, with only having this structure, it's not sufficient to learn more complex statements of that form, where, for instance, you have multiple events A, B, C, and then some operation leading to C. Because many derivations will be something like A, up 2, something which is not too helpful for the system. I mean, it's not wrong to derive something like that. It's just not very useful, because whenever it has the goal up to it, it doesn't need to know how to realize it, because it can directly make it true. It can directly invoke this operation and make it true whenever it desires to. So all the resource that is spent on such statements is maybe not spent to...
What's the current situation in the current implementation for that kind of thing? Do we filter out that type of conclusion, or is still allowed and make it just let it to be forgotten?
Currently, it can be derived by other multi-conditional inferences. This can happen that it, for instance, introduces a certain operation at a certain point by comparison with another implication. This can happen, but what cannot happen is that this structure builds, this event-back mechanism builds such a statement cannot happen. And this is because we changed the control mechanism in such a way that operations play a special role in the processing of how such statements should be derived. And this is what we will see now. This is more complicated. So let's delete this. The idea is to have a separate back for operations. So we have something called operations back, which is a back of the recent happened operation events, like op1 or op2, different operations that happened recently. So it's similar to event back. Which includes A and B. So we have a separate back for operations, and there is more that is happening. Namely, whenever operation is executed, for each operation there is still a concept that corresponds to this term. So there can be a concept for op1, and this concept has something called last events or preconditional events, I think we called it. Which basically what it does is the following. Whenever a certain operation is executed, like operation 1, then this concept references all the events in event back that happened, that existed. So basically, when this was the state of the event back, the previous observations, and then this operation was executed, then now pre-events references A and B. So this this structure now references the event that happened before. Why is this relevant? Because we want to build statements of that form. So next time, when there is a new event C coming into the system, it can directly build such statements by simply sampling an operation from the operation spec and sampling a pre-event in the concept of that operation.
But how much do you want to remember?
There's a fixed size here, so it's basically it cannot be bigger than the event spec. The pre-events here can only be as big as the event spec in the system, and it also doesn't copy all the events. It's just a reference to the events that are already there. So it's similar to how we reference tasks by task links. And so the idea is, so we can do things. We can still, when the new event C enters the system, it can still sample from event spec to build things like A, C, or if B is sampled, can also build such implications. But additionally, it can sample an operation. For instance, operation 1, which corresponds to this concept, and sample some pre-event to build something like A of 1 C.
Okay.
So with this mechanism, we exclude all the options we do not want to build, basically. So it's so with this simple mechanism, we ensure that the statements we build will be of this shape: precondition, operation, consequence.
It'll be more efficient than the previous way, which is going to do induction step by step. That's for sure.
Exactly. And this can still be, for instance, if there is something like A and B happened before, it might be that event spec derives something like the sequence AB. So if the sequence is now in there, AB, then it can also build things like AB up 1. So it's still step by step. If the precondition has to contain multiple events, it's still necessary to do this step by step with the iterations in event spec. But now when a new event comes in, it can directly make use of an existing sequence that was seen. So it doesn't have to rebuild it. It can just sample it from the pre-events, because it will also be referenced here. Okay. So it can directly build the statement by sampling an operation and sampling a pre-event into operations. So
but can we still support different condition of different lines, or with no condition or very little condition? Or all the condition will come with event back attached to it?
Currently, all conditions will be events from event spec or combined events from event spec.
Yeah, but you can still have, for example, you can still have the version with only A as the condition and only B as the condition, as well as A and A fail followed by B, right?
Exactly.
Okay.
So when this sampling happens, so it's so so it's basically two ways to form a hypothesis of how to realize C. It's like either you can find ways of let's say, how can we explain a certain event? Either we can somehow realize that event by ourselves, or there can be external conditions that lead to that event. And those are really separate because by the event, by sampling, we build external explanation for how the event can be realized. While with the operation back sampling, we build an explanation of how to realize that consequence by itself. And I think both is important. For instance, there are certain events which we cannot explain by own operations. We cannot explain we cannot explain the sun rising every day by own operations. It's something that externally happens where we have no influence to. On the other hand, some other things like if I want to write the letter A on this whiteboard, it won't work if I don't invoke on motor actions to produce the letter. So it's basically two ways to explain an event, by external or in terms of own operations. And some events can be better explained by external causes, like if it's 5 AM in the morning, then likely the sun will rise in the next 2 hours or something like that, while certain other events can only be reproduced if you, or mostly, it's not exclusive, it can be both, that you can realize a certain event by yourself, but it can also be externally realized somehow. And that's also interesting because to some degree we want an HEI system also to understand how to realize a certain core, not to also understand how a certain event can happen even if itself cannot realize the event. It's for instance, a reinforcement learning system cannot grasp the external coherences. It can only grasp when I invoke that operation, I can expect this reward, but it cannot understand something like some term.
I guess we do have a better model, do we? It's not very easy to read. I don't know what.
I can go to watch it. So done. Something like that would be produced by event.
Yeah.
Well, something like just an example.